Now, if you want to magnetize any sample, then you have to place it in the uniform magnetic field. So if you want to magnetize any sample, then you have to place it inside the solenoid. So in other words, we can say now the core of the solenoid that is made by that particular sample. Now that some sample will be magnetized one. So if it is magnetized one, then its own magnetic field will be also developed inside the solenoid. So if the sample is placed inside the solenoid, then the resultant magnetic field, that is B0 plus Bm. B0, that is due to the current flowing through the solenoid, and Bm, that is the magnetic field of that sample, which one is now magnetized one. So its sample behave as magnet. Now B0, that is mu0 into H. Bm, that is the additional field due to magnetization of that substance. But here Bm, that we can write mu0 into M. So resultantly, we can write the magnetic field B, that is equal to mu0 Ni plus mu0 into M. Okay. This one you have to accept the magnetic field of the sample, that is mu0 into M. Because experimentally we can observe this thing, the magnetic field directly proportional to the magnetization of the sample. Now Ni, that is equal to H. So we can write mu0 H plus mu0 M. Clear up to this one? Now, from this equation, mu0 H plus mu0 M, we can take mu0 common. Therefore, B equal to mu0 into H plus M. So you can write from this equation B upon mu0, that is H plus M, and H, that is B upon mu0 minus M. So magnetic intensity H, that is N into I, as well as we can write that is equal to B upon mu0 minus M also. This is one result that is useful to solve the problems. Now experimentally we can observe this thing, the magnetization of the sample, that directly proportional to magnetic intensity. See H, that is Ni. If Ni is more, means the total current per unit length in the solenoid is more, there inside the solenoid, the magnetic field of the solenoid becomes stronger one. And if magnetic field produced by the solenoid becomes a stronger one, then the magnetization of the sample placed inside it, that also increases. So here we can write M, magnetization of the sample, that directly proportional to H. Okay. So M, that is equal to chi H, where chi, that is known as magnetic susceptibility of that particular sample. Magnetic susceptibility, that is the susceptance of magnetic field by the sample. Now, if we substitute the value of M, that is equal to chi H in this equation, then we will get B, that is equal to mu0 into H plus chi H. Now take H common. So you can write mu0 into 1 plus chi into H. Now, this 1 plus chi, that is called the relative permeability of that sample. So we can write B, that is equal to mu 0 mu r H, where mu r, that is 1 plus chi. But here you can rewrite this one like this also, mu 0 into mu r, that is mu also. So resultant magnetic field now we can give by B, that is mu into H, where mu, that is the permeability of that particular sample, that is mu 0 mu r. Clear to all of you? Initially, when the sample was not placed inside the solenoid, at that time the magnetic field inside the solenoid was mu 0 into H. But now, when the sample is placed inside the solenoid and its magnetization takes place, so the resultant magnetic field, now that becomes mu 0 mu r H, it implies that the resultant magnetic field becomes mu r times more than initial one. Clear to all of you?